Hello everyone, myself J. Vinay Kumar, and today the subject which we are going to deal is DC machines and batteries. In the previous presentation, we have already learned about the multiple voltage method of speed control for DC shunt motor, and what Leonard method of speed control for DC shunt motor. And we have learned about the advantages and disadvantages of what Leonard method of speed control for DC shunt motor. And also we have learned about the calculations on flux control method, or it is also called as field control method of speed control for a DC shunt motor. And we have also solved some problems on armature control method of speed control for DC shunt motor. And in this presentation, we are going to learn about the speed control of DC series motor by voltage control method, and speed control of DC series motor by armature control method. And also we will learn about the speed control of a DC series motor by flux control method. Now let us see the advantages of speed control of DC series motor and also their applications. These DC series motors are used for electric traction. Mainly these motors are used in traction because of its high starting torque and easy speed control. And it is also used in cranes and hoists. And we also use this DC series motors in trolley cars. And in conveyors also DC series motors are used. And in rapid transit system and electric locomotives, these motors are used. Mainly to control this DC series motors, there are three methods. One is the voltage control method. In this, we control the voltage. By changing the voltage, the speed can be varied because EB is directly proportional to speed n. And the second method is the armature control method. In this method, we use diverters, which I will be explaining in the next slides. The next type of speed control method is the flux control method. Now, let us see the first method, that is the voltage control method. In this method, the voltage control method, there are two ways. That is, one is the series motors can be connected in series. By connecting them in series, we can change the applied voltage. And the other one is the parallel one. The voltage across the identical DC series motors of two or more is varied by connecting them in series or parallel or series parallel combination. Here in this diagram, it is clear that these two DC series motors are connected in parallel. In parallel connection, 4 times the speed can be varied as compared to the series connection can be obtained. The advantages of this method is different speeds by connecting series parallel or series parallel connection in electric traction system, and this method is used in crane tractors due to its high starting torque. Now let us see the next method, that is the armature control method. Here a rheostat is connected in series with the circuit, and EB is the back EMF generated in the armature, and IA is the armature current, and RSC is the series field winding resistance, and IL is the load current, and V is the applied voltage. Okay, in this method we are connecting a rheostat in series with the circuit. Rheostat is nothing but it is a variable resistance. Its resistance can be varied. Here a variable resistance R is connected in series with the armature. We know that N is directly proportional to EB from the back EMF equation, that is EB is equal to 5ZNP by 60A, except N, keeping all other terms as constant, then EB will be directly proportional to speed N, and we know that EB is equal to V minus IA RA. Here in this circuit we have inserted an additional resistance R. So the back EMF equation will become EB is equal to V minus IA into RA plus R. Here IA is the armature current, RA is the armature resistance, and R is nothing but it is the resistance inserted in the circuit which is connected in series. So now N will be directly proportional to V minus IA into RA plus R, where R is the additional resistance. When higher the variable resistance, higher the voltage drop means IA into RA plus R. When this becomes higher, the lesser the EMF will be, and hence lesser the speed. Means as we increase the value of variable resistance, the speed of the motor gets reduced. And in the same fashion, lesser the variable resistance, lesser the voltage drop, that is IA into RA plus R, and higher the EMF, and hence higher the speed. In this method, the speeds below rated value can be obtained. Now, let us see the third method of speed control of DC series motor. In this field control method, we know that the speed N is inversely proportional to EB by phi, where N is the speed, EB is the back EMF, and phi is the flux. Here, when we control the flux, the speed can be controlled. Means when the flux phi is reduced, the speed becomes more. And when we increase the value of phi, the speed of the DC series motor will get reduced. In this circuit, we connect a rheostat in parallel with the field winding. You can see here, this is the rheostat which is connected in parallel with the field winding. And here EB is the back EMF and IA is the armature current and RA is the armature resistance and RSE is the series field winding resistance and ISC is the current flowing through this series field winding and IR is the current flowing in the rheostat. Here IL is the load current which is equal to ISC plus IR and V is the applied voltage. As I have already said, change of flux changes the speed of a DC motor and this method is called as the field diverter method because here we are diverting the field current into a rheostat. I have already said a variable resistance R is connected across the field winding. In this, a part of the load current flows through the variable resistance under constant load. This makes the series field current reduced, reducing the flux phi. When the flux gets reduced, the speed automatically gets increased. Reduction in the flux increases the speed of the motor. Above the rated speed can be achieved by this method. Now the next one is, that is the next method is the armature diverter method. In the previous method, we have connected a rheostat across the series field winding, whereas here we are connecting a rheostat across the armature, and here this is the rheostat, nothing but the variable resistance, and the current flowing through this variable resistance is IR, and EB is a back EMF, and IA is the armature current, and RA is the armature resistance, and RSC is nothing but it is the resistance of field winding, and IL is the load current flowing in the circuit, and here V is the applied voltage. As I have said that a variable resistance is connected across the armature. At constant load, the additional current IR is equal to V minus I1 RA by R, will flow through the series field winding. An additional current which is flowing, represented as IR, makes more field flux and hence reduction in speed. This is from the formula N is inversely proportional to 1 by 5. When flux becomes more, the speed gets reduced. And from this method, the speeds below the rated value can be obtained. And the next type of method is the tapped field control method. Here, this is the circuit for the tapped field control method. In this is the armature, and this is the field winding, and this field winding is tapped at 3 points, 1, 2 and 3. These are the tappings. Here EB is the back EMF and IA is the armature current and RA is the armature resistance. And here we have provided tappings on the series field winding RSE, and this IL is nothing but it is the load current flowing in the circuit, and V is the voltage across the series motor. Here in this tapped control method, the number of turns of the field winding can be varied, thus changing the flux and resulting in change of the speed of the motor. When one or more turns are shorted, the effective ampere turns will be reduced, providing less flux. And when the flux is reduced, the speed of the motor gets increased. And from this method, the speeds above rated value are obtained. However, by increasing the number of turns, more the turns required for rated speed, any speed can be obtained. In the figure, when the contact is on tapping number, that is on either 1, 2 or 3, if it is on 1, then the motor run at rated value of the speed, and if the tapping is on number 2 position, then this DC series motor runs below the rated speed, and if the tapping position is on number 3, then the speed of DC series motor runs at above the rated value. Okay, now let us see a small quiz on this presentation. The first question is, in voltage control method of speed control, the voltage across the motors is varied by connecting them in option A is series connection, option B is parallel connection, and option C is series parallel combination, and option D is all of the above. We have already discussed this. The voltage control method of speed control. The voltage across the motor is varied by connecting them in series connection, in parallel connection, and also in series parallel combination. Yes, so the answer is all of the above. Now the second question is, how many times speed varies when the series combination of two DC series motors are changed to parallel combination with the same applied voltage. Option A is 2, option B is 3, option C is 4, and option D is 5. The answer is 4. It is option C. Now let us see the next one. When additional resistance is connected in series with the series winding of a DC series motor, option A is voltage drop gets increased, option B EMF reduces, option C speed reduces, and option D is all of the above. So when additional resistance is connected in series with the series winding of a DC series motor, as the voltage drop increases, which reduces the EMF. When the EMF gets reduced, the speed also reduces because EB is directly proportional to N. So the answer will be all of the above. Now let us see the fourth question. What are the different field control methods of speed variation for a DC series motor? Option A is field diverter method. Option B is armature diverter method. Option C, tapped field control method. And option D is all of the above. What are the different field control methods of speed variation of DC series motor? Field diverter method is one method, armature diverter method is other one, and also tapped field control method is also one of the method to control the speed of a DC series motor. So the answer will be all of the above. Means option D. Now let us see the next question. Tapped field control method of speed variation for DC series motor gives option A rated speeds, option B above rated speeds, option C below rated speeds, and option D all of the above. Tapped field control method of speed variation for DC motor gives rated speeds also, it gives above rated speeds, and also it gives below rated speeds. Means by changing the position of the tapping, we can achieve all the above speeds. So the option is all of the above. That is D. Here it is given as B, but it is wrong. The option is D. All of the above. From this presentation, we have learned about the applications of DC series motors, and we have already learned about the voltage control method of speed control for a DC series motor and armature control method of speed control for a DC series motor, and also we have learned about the flux control method of speed control for DC series motor. And let us see some frequently asked questions in this topic. First question is, what are the applications of DC series motors? And second one is, explain how the speed of a DC series motor is varied by voltage control method. The third one is how the speed of a DC series motor is varied by armature control method. The fourth one is explain how the speed of a DC series motor is varied by field diverter method. And the fifth question is explain how the speed of a DC series motor is varied by armature diverter method. The next one is explain how the speed of a DC series motor is varied by tapped field control method. Thank you very much for listening this presentation with patience.